everyone. Today we will start to learn another mechanism called a cam and follower. And this lesson is broken into two parts. We will be covering part 1 today. So in this part 2 of the lesson, you will be looking into what are cams, the different types of cams, and of course how it works. Alright, before we actually talk about cam in detail, I want you to make some observation on these two examples that I put it out on this PowerPoint slide. I want you to pay exactly attention on this part. This is a front view, so basically, actually this is a round crank. The person is turning the round crank, and the movement is transmitted to all these little parts, and in return it pushes the follower up, and then the caterpillar is moving. Now, this is a better view in 3D, right, where this is actually the same thing. Okay, the same thing, right? So you are turning this and return because of that axle that has been connected. It turns. This is what we call the cam here. Right? This is the cam here, and then that's a follower. Right? In return, it pushes the leg of the person on top. So what exactly is cam? Well, like what you've seen in the earlier example, it is best described as an odd-shaped wheel, and most importantly, what it does is it converts, right? Let me put a highlighter on it. It converts, right, a rotation motion into reciprocating motion. Okay, right? As the cam rotates, the follower follows the shape, or rather the profile of the cam. That's why it's called follower. The different shaped cams will cause the follower to move up and down in different ways. So basically, if you want the follower to have a different reciprocating movement periods, all you need to do is to change the shape of the cam. And in more detail, cam, hang on, let me do my pen up. Okay, cam is fixed to a shaft. Okay, this is the cam. This cam and the shaft, right? Shaft right here, right, is fixed together. So as the shaft turn, the cam turn, right? But the cam is not fixed to the follower, right? So when this cam is moved, this is what we call the cam profile. Okay, this is a profile. As we turn the cam, the follower will follow the profile of the cam and move accordingly. There are two types of movement that you can see at the output of the follower if you were to apply a cam. The cam will be rotating. The cam will be rotating. But at this point, the output of the follower is going reciprocating up and down. On the right hand side, the cam is also rotating. See, all the cam's input are all rotation. I look at the output of the cam of the follower. In this case, because of the way it's mounted like a lever, it oscillates. And again, this is another example. As the cam rotates, the follower moves accordingly. You look at the animation, you will see, right? The exact distance it moves depends on the shape of the cam. So if the cam, in this case, has half of the cam shape, right, is actually a circle, there's no movement expected of a follower, you will see that the follower actually stop for a while before it moves up and down. In your syllabus, there's 3 important cam shape you must know, namely the eccentrical cam, right, where the shaft is not in the center of the circle, is offset from the circle. A pear-shaped cam, right, where the cam looks like a pear shape. And last but not least, a snail cam. Now let's look at how the follower will behave based on these three different types of cams. I would like to start off with the first one, which is the eccentrical cam. You notice that this is the height of how the follower will be moving, and at the bottom now here means the degrees of the cam being turned. In other words, when this cam is at 0 degrees, the follower is here. When this cam turns to 90 degrees, it starts to drop down. When it turns furthermore to 180 degrees, it drops furthermore. You will only start to get move its way up when it goes beyond 180 degrees towards 270 degrees and towards 360 degrees of the cam turning. So we can notice that the follower on this cam do not stop moving. It was always constantly moving. Now let's look at the other cam, which is the pear-shaped cam. Look, when it first started at 0 degrees, it was at this height. When it move into 90 degrees, it start to drop. Alright, it start to drop, the follower start to drop. But from 90 degrees to 270 degrees, you will notice that at this period of time, the cam follower is not moving. We call this dwelling period. And in this dwelling period, the cam follower is not moving until 270 degrees onwards. It will start to move up. So this is the follower behavior for a pear-shaped cam. Last but not least, let's look at the snail-shaped cam. It is always moving until when it reaches a certain point, it will start to drop down. Right? This indicates a sudden drop. So that's how the follower will behave on a snail-shaped cam. Some example where you can find cam usefulness in machines. They are usually on sewing machine. You can find them in toys as well. These are some more design ideas that you can make use of cam. Basically, they are now quite widely applied in toys. Okay. And all of them end up quite interesting. You can always go to this link, right, to look into more example how some students have cams in their toys.